A bit of a tough problem there. Let me kind of show all my work real quick in case you just want to double check that at the beginning. There's A and B real quick there, and then let me slide that. There's all my work for letter C. I thought letter C was the toughest part of this thing. We'll definitely slow it down when we go through there, but it didn't have room on the actual test itself right there. But for letter A, gives us a graph of G prime, and then it's asking us for G of 3 and G of -2 right there. So there's actually two ways that you can approach this right there. What I'm gonna do this as is when I wanna find G of 3, I'm gonna start that as G of 0 plus the integral from 0 to 3 of that G prime. You know, to get from G prime to G, you have to integrate. So that's why we're integrating the G prime. But this is, to me, is like those velocity position problems where I say find the position of something, you gotta take into account the initial position. It tells us that G of 0 is equal to 5. So that they're telling us, hey, when t is equal to 0, that's where we're at. So when I want to find where I'm at after 3 seconds, I'll start where I'm at initially at t equals 0, and then I'm going to pick it up where I left off and integrate it to where you want to go. Like if it would have told me G of 1 was equal to 5, I would have had G of 1 right there, and then I would have started that at 1. So that would have been like where I was after 1 second, and then you integrate between 1 and 3. That'll tell you where you went in between 0 and 3 seconds. So this tells you where you're at initially, and then this is kind of giving you where you went in between 0 and 3. So same thing when I did G of -2. I started with what I was given, the G of 0, and then I'm going to pick it up where I left off and then always go to where I'm supposed to go. Just on this one, when you see the integral between 0 and -2, then you're going to have to flip it, make it from -2 to 0. You always want to go least to greatest on that. And then when you have to flip the numbers like that, that's when you switch the sign of that integral right there. So that's one way that I think I would like for you to get the hang of, because it's a little bit quicker than the other way that I have working it out, or that I will mention that. And then here we're given that that's 5. We're given that the G of 0 is 5. And here you're going to do the area. This is your G prime graph, and you're supposed to integrate that. You don't have a function that you can integrate it and then plug in the 3 and the 0, so you have to do the area. And that's why it's giving us some geometry shapes right here. And so in between 0 and 3, you have a quarter of a circle. So I did pi times 2 squared divided by 4. And then I drew in a little line right here. That's 1/2 times 1 times 3, 1/2 base times height. That was a 3. That was just a pi. That was 3 over 2 plus 5. That's 10 over 2 plus 3 over 2. So you did 13 over 2 plus the pi right there. And in here, I had to do the area between -2 and 0. That's that same thing. That was pi there. That's also a quarter of a circle there. So that's pi r squared divided by 4, which is just pi. And then you get that 5 minus pi. So I think we might have seen that a couple times there, but it still might be kind of new for us. And then another way that you're more familiar with that, let me kind of dig that out real quick, is if you have to figure out G of 3, for example, I'll just show you one of them. You could integrate the G prime between 0 and 3. You choose the 3 because that's what you're trying to figure out, and then you choose the 0 because, again, that's what we're given right there. And so when you integrate G prime, you get the G of x, plug in the 3, plug in the 0 because you have a definite integral there. So you get G of 3 minus G of 0. They told us G of 0 is equal to 5. We're supposed to figure out G of 3. And then here you would have to do the area between 0 and 3. Still get this pi plus 3 over 2, and then add the 5 to both sides, and then you're going to get like that same thing right there. So that's another way that you could think of it. Either way is acceptable. Just get it right and have some work there. Have that justification down. Letter B, I like letter B on this one. It wants to know, find the point of each point of inflection on the graph of G. So again, this is G prime. I know that G has an inflection point where the G double prime changes sign. And then to get from the G prime that we're given to the G double prime, I need to do a derivative, which is a slope. So the G double prime is the slope of that given G prime graph. So if I want to know where does a second derivative change sign, that same thing as knowing where is the slope of that G prime graph change sign. That means where does the G prime graph change direction? This, we have seen this concept quite a bit. So where the G prime graph change direction, you're talking from going from uphill to downhill or downhill to uphill. So here it's going up, and then here it goes from increasing to decreasing. So at x equals 0 is going to be 1, and there it goes down, and then it goes up. So x equals 2 is another one, and then it goes up and then goes down. So x equals 3 is another one. So we got 0, 2, and 3 as our inflection points. Since the G double prime, or the slope of that G prime, changes sign right there. All right, now letter C kind of sucks, but you got to at least try to do something on these, and you got to at least try to get partial credit. Like this first couple parts right here, they give you a couple points if you're just kind of doing a derivative and setting something equal to 0 right there. They can give you a couple points for that stuff there. So try to do the best you can. Sometimes these are straightforward. Sometimes these are a little bit rough to do, all right? Now, when it gives you a new function, it says find the x-coordinate of each critical point. So let's just focus on that first. The critical point we know is where the derivative is equal to 0. So it gave me that function. I'm going to take the first derivative, and then, so the derivative g is g prime. The derivative of that is just multiplied by the power decrease the power by 1. You're going to get an x, and then we need to set that equal to 0. Now, what I did is just added x to both sides. I want to know where is g prime equal to x. Now, you know what that is. Like if I give you like where is 2x plus 3 equal to 5, that's where like the 2x plus 3 line intersects the y equals 5 line. You got to figure out where these two graphs cross. So you already have the g prime of x graph. And what I'm going to do, I'm going to draw in like a y equals x line. So you're talking like 1, 1, 2, 2, 3, 3, and then 0, 0. So you're talking, this is my y equals x line right here. And so when you see g prime of x equal to x, that's when the graph of the derivative is equal to the graph of that y equals x. And so we already see that we got this point right here. See how I got that 3, 3? That's simple. So I jotted that down right away. And then also I got to figure out what this dot is right here. And it didn't look like it was anything nice, like 1.5 or 2 or something like that. I didn't know what that x value was. And so here's what I'm going to do. I'm going to do the intersection point between this semicircle graph and the line graph. Like it's an algebra 1 problem here. So I know this is y equals x. I got the equation of that circle there. Remember the equation for a circle is x squared plus y squared equals r squared. So we're talking about x squared plus y squared. And we could tell the radius of that thing is equal to 2. So 2 squared is going to give us 4. And then I want to solve this for the y. So that's where I got that y equals the square root of the 4 minus the x squared right there. And I know the y is positive because it's the top half of that semicircle. If it was the bottom half of the semicircle, then I can choose the negative when you square root both sides and remember the plus or minus there. But see, that's where I'm getting now. So I want to know where is that. That's like what the g prime is equal to right there. And I want to know when is that equal to the x. So I had to solve this equation, square both sides, combine like terms, square root both sides. And I mean, you get the plus or minus in there, but we know this point of intersection that we're looking for is a positive x value. That's why I chose the positive answer, that square root of 2. So now we get the square root of 2 and that x equals 3 right there as a 2 critical number. So if that wasn't hard enough, then they want us to go a little bit further. And they want us to now that we found the critical numbers, we want to calculate at each one, is it a relative max, a relative min, or neither. And so anytime I do a max, min, or neither, you're comparing the derivatives on each side. So I did like a little x, y, y prime chart, except I didn't really need the y row. So I just did an x, y prime row, put in the square root of 2, put in the 3. That's where our critical numbers are. So that's where the first derivative is equal to 0. So I kind of circle those, and I chose numbers in between. And then I had to figure out what the sign of that first derivative was. Was it positive or was it negative? I remember the first time I worked this out, I spent entirely too much time like finding the exact numbers and doing a lot of stuff with areas and stuff like that. Forget all that, man. So like, you just need to know whether it's positive or negative. So here's what we're going to do. Here's my derivative of h. So I got my h prime is g prime of x minus x. That's what I'm working with right here. So when I plug in my test points, when I plug in 1, I have g prime of 1 minus 1. When I plug in 2, I got g prime of 2 minus 2 and g prime of 4 minus 4. And I need to figure out whether those are positive or negative. So if we look at our graph, g prime of 1 just means on your derivative graph, which is what this is. When x equals 1, what is my y value? So when x equals 1, my y value is up here. Notice that that is bigger than 1. So if I take a number that's bigger than 1 and I subtract 1, I'm going to get a positive number. That's how I got the positive right there. And here I'm going to do g prime of 2 minus 2. So g prime of 2 means on my derivative graph, when x equals 2, what the y value is, that's 0. G prime of 2, I got the point 2 comma 0. G prime of 2 is equal to 0 right there. And so I get 0 for g prime of 2. And if you subtract 2 from that, you're going to get a negative number. And then when I plug in 4, I got g prime of 4 minus 4. So at x equals 4, that's going to be, here's x equals 5. So x equals 4 is right here. And when I'm looking at, that number looks like it's a little smaller than 1, or even if it was 1 or around 1 or smaller than 1, you're taking a number around 1 and you're subtracting 4 from it, which is still going to be a negative number. And so it does say to classify, it just says find the relative max or min or relative extrema, then you're going to give me one answer right there. But it says that each of the critical numbers, you got to classify it. So I got to have some justification for each one. So we know if the derivative switches from positive to negative, that means our original function is going to change from increasing to decreasing, making that a relative max right there. So the chart is not the justification. The chart helps us organize it and help us get the answer. But this is your justification. You got to stress relative max at x equals square root of 2, since h prime changes from positive to negative. If the derivative switched from minus to plus, then that would have been a relative min. And then at x equals 3, notice the derivative stays the same sign right there. So that means your function is decreasing, and your function is still decreasing, which means it's not a relative max or min. It's neither. So that's why I got neither at x equals 3, since that h prime does not change sign. Roller skates.